My name is Randy Syring. I'm going to cover database testing today. Hopefully well. If not, you're welcome to tell me. Just be nice about it. I want to talk today mostly about concepts. I've sat in talks before where people get very detailed into the code, and the reality is that, at least for me, I very rarely can follow along in the seats like the person who wrote it, and so I usually get lost pretty quickly. Also, there's also usually, when you get detailed into the code, there's a lot of assumptions being made about somebody's environment or about maybe how they're used to coding that just can't be communicated in a 45-minute session. So we're going to look at a few code snippets, but for the most part, I'm going to be talking about higher level concepts. However, at the beginning of the slides are out there on GitHub. So if you want to look at some of the details, there's also a companion demo application, which isn't a great demo, but it does have some particular code in it that I've ripped out of stuff that we use in production and just kind of dropped it in there that you can take a look at and modify to your own uses if you like. I'd much rather this was more towards a discussion than a pure monologue. So if you see something, you have a question, maybe you think what I'm saying isn't going to work in your context and you wonder why or want to talk about that, please bring it up. I'd rather have that. Yeah, and wait for a mic, please. I'd rather have those discussions. I'm going to go into this a little bit, but I have a particular background and I've been doing coding in a particular way. Your environment, your background may not be the same, and so what works for me may not work for you, and I'd actually be interested in knowing if you see something, you go, this wouldn't work for us because X, Y, and Z, and maybe we can have a little discussion about it. If it's going to be way in the weeds and it's very particular to your use case and it's not really going to benefit the group, then if you can just hold on to that till afterwards, I'll hang around outside the room and we can have a chat if you're interested. I said I was likely going to have extra time because I wrote that at the very beginning of the slides, but now since I see the number 38 staring at me and I realize I have about a minute a slide, I'm beginning to wonder if that's true. Don't be afraid to ask questions. I don't know. If I don't know, I'm not going to feel bad. I hope you won't feel bad, and we'll just try to figure out the answer together some other time. So I've been building database-driven web applications for about 10 years. The first 4 years of that were in PHP, but last 6 years have been in Python. About the same time I started Python, I realized, or I started to learn about unit testing, functional testing, automated testing, and have really bought into that as a model. I evangelize a concept that I think I've coined called test-centric development, which is kind of test-driven development, but with some leeway for the realities of business and the reality that sometimes it doesn't pay to get 100% test coverage because the customer doesn't want to pay for it. So if we get 80, 90, 70 sometimes, and that's beneficial to the customer, then that's what we're going to shoot for and we're going to drive on. Nothing that I'm doing is operating at scale, right? I don't have data centers worth of servers. I'm not doing any of that. If you do, great. You probably have a team that you can talk to about performance and database testing. This has all been developed in a small shop where it's either been me and a few other guys, or sometimes just me. We do have a pretty large app that we've been working on for about 6 years. Currently, we have over 5,000 tests across 207 tables. A lot of those tables are highly integrated with each other, a lot of relationships. It takes about 24 minutes to run all of our tests, which isn't ideal, but when you consider that a lot of those tests are actually running multiple tests in the same test method or test function, our test numbers are really probably up around 25 or 30,000. I know there's a movement I've heard people talk about trying to basically mock away the database server, and I just find that not possible, at least for what we're doing. Maybe it would work in your context, but the database server, in my opinion, is such an integrated part of the application that I'm going to be using the database server, and I hope that's okay with you. And as always, your mileage may vary because your background or your situations may not match mine. So why database testing is hard? So I really thought, I was trying to distill this down to what are the things that make database testing in particular more difficult than, let's say, a unit test without any kind of database interaction. And here's the things I came up with. Number one, you have to have a way to set up the schema for the test. Number two, you have shared state. So some tests need the database in one way, some tests need the database in a different way. And if you're not careful, that data is starting to run into each other and cause conflicts. At least for me, I have a serious lack of creativity, and I've got foo, bar, and baz, and after baz, I don't know what other string to use for test data. So I really get irritated having to come up with like fake names or fake statuses. Like I just don't even want to worry about any of that, because a lot of times I just need the object. I don't really care what data is in it. And database testing can be slow. Like I said, it takes us about a half an hour to run all the tests for that large application, and so that poses some challenges when you get to the point where it takes a half an hour to run the entire test suite. And we'll talk about that at the end. All right, so I'm interested. What have you found makes testing databases particularly difficult compared to other more easier testing that you've done?
When multiple people are in the environment, so you have multiple teams that are doing testing, maybe some are not doing TDD or cleanup after themselves, so you're injecting data that messes up somebody else's test.
Okay, so basically there's other people on the team. What's that? Yeah, so there's other people on the team that are putting data in the tests, and those are kind of messing up your tests. In those situations, do you have a test database that you're sharing, or is this all happening in your own test instance, and it's just their sloppy code that's injecting data, or do you actually have a shared database?
It's actually a shared database.
A shared database, okay. So anybody else, why is testing difficult in particular?
So when you're doing things like inserts and updates and stuff like that to the database, you don't necessarily, your code is not going to have results. Normally on a unit test, you have results, and you look at the results, and that's how you know it's tested. If you just did an insert or update to a database, there's no results to check that it's right.
Okay, so he said I guess you got that because it was on the mic. Anybody else?
There's differences among databases and SQL dialects.
Differences amongst databases, SQL dialects, sure, absolutely. So I might have a test, if I have a library that's supposed to work in Postgres, Microsoft SQL Server, and SQLite, I have to test it against all three databases.
Plus, I also use an in-memory database for the speed issue, and that often has limitations that bring its own.
Yeah, okay, so you're going to use an in-memory database, and that has some issues of its own that enter it. Anybody else, anything major?
I actually have to write tests. That's usually the biggest hurdle.
Oh, he says you have to write tests?
Yeah.
All right, well, that's a different talk. Okay, all right, so what we've really talked about are things that make writing tests or make the tests themselves liabilities rather than assets. So I don't know how many of you are familiar with accounting, but these are some basic principles. In accounting, you basically have assets, liabilities, and expenses. When you don't write tests, everybody tests their code, even if you just throw it at the customer to test. Everybody tests their code. A test that is not automated and part of the test suite is what I consider an expense. It costs you time and effort every time to test. A test that's a liability is a test that's written, but it actually weighs down the project more than it benefits it. And then a test that's an asset is something that actually contributes to the overall value in a positive way of the project itself. I prefer assets, not expenses or liabilities. And so the idea that I have is that I want my tests to be assets. How can we make database testing assets and not just a big pain in the butt that everybody hates doing, which means what? They won't do it, right? If it's hard to do, if it's out of the ordinary hard, people will simply not do it, and we have to deal with that. So the list that you see up here, we're going to go, this is basically the rest of the talk. We're going to talk about, in order for tests to be assets, here's the things that I think we need to think about as we're writing our tests to make sure that the test turns out to be an asset and not a liability. The first thing is, it has to be easy to set up. And here I'm speaking specifically about the project. I should be able to check out the project and run the test with just a minimal amount of effort. And if anybody's got a laptop, I've got a challenge coming up. If you're running Ubuntu and got Python 3.4, I got a challenge for you. We're going to see if it works. If nobody does, and that's fine. Let me know. Raise your hand if you got one. The second thing is we want to make it consistent. One of the things that was really frustrating for me on that big project is we had a point in time in the project where it was getting pretty big. We had a lot of libraries, and what would happen is the developer who was primarily working on it, the test would pass for him, and I would jump in 3 months later, not having done it recently, but needing to look at a problem, and I'd run my tests and I'd get like 500 failures, and it would just irritate the pants off me. So I realized pretty quickly that what was happening is our libraries were getting different versions, and there was incompatibilities and bugs in some versions that he found, but we weren't doing a good job of communicating dependencies and versions across the project. I'm not sure that this is the right word. Idempotent, I know what it means. I'm just not sure that this is what I'm really trying to say here. But basically what I'm trying to say is that my tests should run the same way, regardless of whether they're run in isolation all by themselves or whether the entire test suite runs. And what I mean by that is there really shouldn't be anything that any other test can do to mess up my test from running. And we're going to talk about how that comes into play later.
Idempotent actually means if you run the same thing more than once, you always get the same result.
So maybe it works
like
there.
Increment is not idempotent because you after you do
you
it
add
the
one
second
each time.
You're 2 up.
Okay. We also want to make data creation very easy. We want to enforce good patterns because I don't know about you, but my memory's getting worse. And we want our tests to be as fast as possible because when tests are fast, people will write them because they iterate very quickly. And finally, we need to be flexible. Our tests need to be able to roll with the punches when the assumptions we've just set up don't work. And in particular, thinking here about how do you test migrations. Okay, so the first thing we're going to cover is, are our tests easy to set up? Is our project easy to set up for testing? Did anybody have a laptop? No? You got one? All right. If you're interested, go out to my GitHub page, Syring, and you'll find book orders. And with the README, with the information that's in the README, check out the project and run the tests. And let me know how long it takes you to do. So this is my run. And the only thing that I'm assuming here, actually, I guess I'll go into that. So as you can see, all I'm doing is cloning it, changing directories into the example and running it. And these tests are all running against a PostgreSQL server. Now, obviously, we had to make some assumptions and some agreements, but I can do that because I've got a team and we can make an agreement about what our environments are going to look like. And you guys can do the same. So what assumptions am I making? We've got a convention, or I've got a convention about what the default database connection is. That matches our CI environment. So that means that the same test configuration that works on the CI environment will work on my local machine. That means I don't have to make a special configuration for my particular use of the app. I can simply run the project as soon as I check it out. If that isn't the case, then you add one more step where you copy a template of a configuration, change your variables, and then you should be able to run talks. We also use something called a wheelhouse. A wheelhouse, you can read about it. It's basically compiling all of your project dependencies into wheels and storing them with the source code so that when you install your libraries, everybody's installing the exact same wheel, unless of course you're on different platforms, in which case you've got one for each.
What is a wheel?
A wheel. So a Python wheel is a pre-compiled version of a library. You can read more about it if you want to. I'm not actually. Other than that, like they replaced eggs. If you know what an egg is, it's a new egg. It's the thing replacing eggs. If you're not familiar with talks, I'd highly recommend you become familiar with talks. Integrating talks with your continuous integration environment, if you have one, is really helpful because it means that in order for your tests to run in the continuous integration environment, almost all continuous integration environments are requiring you to set up the virtual environment fresh and then run the tests. If you do that with talks, it means that your developer can run the exact same setup sequence in a local environment that your continuous integration server is going to run, which means that you can actually test your continuous integration environment locally before you push your stuff up. There's some caveats to that, but for the most part it's true. And this is closely tied to our CI environments. I'd ask you why you aren't doing this, but I'm going to skip that part because I'm 14 minutes in and only on slide 10. So what else can we do to make tests as our assets? We can be consistent and avoid environment surprises. So I talked a little bit about this. We want everyone's tests to pass or fail the same. And in my experience, the biggest issue here has been library versions. If you're pushing your database server really hard, if you're on the cutting edge of like Postgres or Microsoft SQL Server, it's possible you might have issues here too with maybe somebody's running the default PostgreSQL 9.3 on their Ubuntu system, but your system needs 9.4. In that case, if you run into that, the first test that your application should do is to make sure that your database is version 9.4, and if it's not, throw in a cert and die, because explicit failures are better than implicit failures. If you haven't thought about how you're managing your libraries and your virtual environment in your project, I'd really encourage you to do that. The Python packaging space is really making some great improvements with wheels, with pips, with requirement files. You wouldn't have to do a wheelhouse. I've found that to be beneficial for our use cases. It ends up making the CI environment really fast and the deployment really fast because all of the libraries are local and I never have to hit pi or go over the network to get my dependencies. They're all checked into the project. But your mileage with that may vary. If you've got different Linux distributions, the wheel format doesn't yet have the ability to specify like different libc versions, and so you can have some issues there. But I'd encourage you to manage to figure out how are we communicating in a project across developers what specific versions of libraries are being both tested with and deployed with, right? Because that's the idea. Whatever you're testing with should be what gets deployed in production. And if you're simply doing a pip install in production and don't have any versions specified, you know, you're running the risk of eventually pulling in a new package that you weren't testing with and having breakages in production because of that. Does that make sense? Anybody have questions about packaging or why that would be important for database testing? It's really important for any testing, but okay. Test as assets, idempotent, avoiding cross-data test data contamination. So one of the things that we do at level 12 is we make sure that at the beginning of any test run, the entire database is cleared of all data and all schema, and the schema is recreated from the ORM. And so if you were not using an ORM, then you'd need some other mechanism of keeping the current schema. Maybe that would be a folder with a bunch of SQL files in it. Whatever you're doing, you should have the ability to take a fresh database and recreate the schema as your app needs it at that place in time. You said you were doing testing on a live database. Does that mean that do you have the ability to stand up a completely new database and get all your schema fresh in there?
No, we can clean up our data, but we can't do what you just said.
Okay, so I worked on a project like that one time. I had to be connected to a database server in their network, which means I had to go over a VPN. There was no way to create the database server fresh. And it took me about 12 minutes every time it was a Java app. Every time I wanted to check my code changes, I had to restart the app, which meant it had to go out and refresh all the stuff from the database, which was a complicated reason why. And it basically took me 12 to 15 minutes every time I wanted to check to see if my code worked. It was an absolute nightmare. So one of the things that I decided early on is that you have to be able to create your schema from the app, whether that's with SQL files or an ORM. I'm privy to SQAlchemy. I think it's one of the best libraries I've ever worked with. If you can work with it or start to bring that in-house, I'd highly recommend it. This code snippet here is from Keg, a project that I'm working on, which is basically going to be a collection. It basically sits on top of Flask and some of the best Flask libraries that are out there and kind of brings everything in so that every time we start a project, we don't have to start from scratch. But you can see some of the code here that's built right into Keg. Keg is making the assumption that if you're going to run a test, your database is going to be deleted at the very beginning, and all your tables are going to be wiped out, and they're going to all be recreated so that you can start with tables that match what your ORM entities are expecting to be in the database. So the first rule for idempotent testing is that the database has to be recreated at the beginning of every test run. The second rule is that your tests are responsible for making sure that the database is in the required state. So if I'm writing a test, I have to make sure that the database is in the state that I expect it to be. You can see I'm doing that here. I've got a test add order. I'm going to add the order, I'm going to query and make sure that the count is 1. Well, what happens if other tests have run and there's more orders in the database? Okay, so it's my responsibility as the person writing test add order to make sure that before I run my test, that order table is completely clear. Does that make sense? And this is just an example of doing that. I'm using, we use PyTest for the most part, or at least are transitioning to that from older projects that use nose. I think it's a great testing library, and there's, you can basically create test setup and module setup, which I guess I'll go into later now that I'm thinking about it, so I'll skip that for now. So, oh, that's what I'm showing here. So that test preparation can be done at the app, module, class, or test level itself. And so, as a test developer, it's not necessary to concern yourself about what's in the database as a whole. All you have to be concerned about is what's in the database now. Somebody mentioned inserting data. If you insert data, how do you know that it's there? Well, if I insert a record, and I know I'm going to insert it with a unique ID, and I just want to make sure that that actually got added to the database, then I do the insert, and then I do a select on that unique value to make sure I get it back out of the database and it's the same object. In that case, I don't care how many, if this was orders or books, I don't care how many orders or books are in the table. It doesn't affect the test, right? In that case, I don't even worry about it. I'm inserting, I'm pulling it out. The only time I'd have to worry about it is if I was using a unique ID that may also already be in the table, in which case I might want to clear the table first. Any questions about test setup or database setup? So this is really key. Like, this is one of the most important things that we do at level 12 is if you're going to write a test and your test fails because of data in the database, it's your fault. It's not the other test's fault, it's your fault. Just change your test to set up the database the way that you need it for your test to work.
So say you have the thing that you're trying to test is in table A, and that's
It's what? I'm sorry.
It's in table A.
It's in table A. Okay.
And you have 5 or 6 or 7 more tables that are dependent on the data that you're trying to insert.
Okay.
So it becomes quite a big of a challenge to populate the to have the entire dependency.
Exactly, because now you guys in your test you only want, let's say, a book to test, but you need the publisher, you need the author, you need the person related to the publisher. Like, it goes all the way up. Yeah.
So have you tried any pattern or?
I have. In fact, I'm going to go into that. I'll go into that here in just a little bit. You can also, I prefer test setup to be at the front, because let's say for instance, I have something that adds 100 orders to a table. Well, I could go ahead and delete all those orders, but the reality is they could sit there for the rest of the test run, and if they're not affecting anybody else, why go through the hassle of deleting them? So our pattern is generally, you know what you need when you're about to write the test or you're writing the test. You don't want to do your cleanup after the test because you don't know what's coming next. It could be the next item in your class. It could be a completely different test depending upon how the test suite is run. So I usually put test setup, data setup at the beginning in the prep phase. However, it is possible to put it in the cleanup phase, and I have an instance of that right here. So let's say that you are doing some CRUD tests. So this is your view, this is the web part, and you know that for your app.get here, you always need a user that's logged in. So part of your setup of your app in order to simulate a request is passing in the user that's authorized. You set this up at the module level at the very top because you know all of your tests are going to use just this one user. If I've got 500 tests, I don't want to set up a user 500 times if it can be the same user, right? Well, that's all fine and good until we get to the users CRUD, and we want to make sure that deleting all the users work. Now what happens? What happens to the CRUD that runs the next CRUD test? So let's say orders tests run after users CRUD. It's going to fail because the user that I'm using is gone, right? The user's CRUD deleted the user. So in this case, it is okay to do a cleanup, right? I want to be flexible here. None of this stuff is written in stone. And what we do is, because test users CRUD is the test that's invalidating the assumption that's been made for the entire module, and you've decided as a developer that it's better to keep that assumption for the other 500 tests that are in there rather than have each test make sure that a user exists, then this test, which deletes it, needs to make sure that that user is put back and the environment is set up for the rest of the tests. I don't like this. I don't like to see this in our code. Occasionally, it's the lesser of two evils. Any questions about this? Test prep up versus test cleanup? So we're going to talk about, go ahead.
Yeah, this can lead to, like, you have to be really careful about this because otherwise we'll run into the problem that he's mentioning. People leave their stale data and then,
So that's why for the most part, the developer writing the test right now is responsible for making sure that it's not possible for any data in the database to fail their test. So if I had a test that was going to count orders, I'm responsible for clearing the table of all orders beforehand so that I know that the only thing under test is the data that my test just put in there. Now, in a situation where you've got a shared database and you can't delete all the data, well, that we're going way back to we're invalidating an assumption I have about how we do our tests, and I don't know a good way to solve that problem. So test cleanup is okay. So data creation made easy. Fixtures or factories? Anybody using fixtures? You like fixtures? Raise your hand if you like fixtures. Okay, how many fixtures do you have, approximately?
Probably
20. 20? Okay, anybody have hundreds of fixtures? Okay, what happens if you add 3 required fields to a table at the very top of your hierarchy? What happens to all your fixtures?
They might become invalid.
They will. No, they not might. They will, right?
Okay,
and
they
so
will.
and then so what do you have to do? So not only do you have to change the table, right? You have to change the table definition or the ORM, the model object. What else do you have to do?
Modify the data factory.
Yeah, exactly. Well, no, wait a minute. We just switched from factories to fixtures.
Why not both?
Oh, all right. You're stealing my thunder here. So this is why, like, I am a factory guy because of this very instance. I think fixtures quickly get out of hand. Ideally, every test is going to create the data that it needs. And because fixtures are so hard to maintain, you're often going to end up reusing fixtures across different tests because it doesn't make sense to do all that work to set up another thing that only has one value different. Oh, I see. You guys didn't see all of them, did you? I was going to try to bring those in, slide the last ones in, but I didn't know on my screen it wasn't. They all showed up at the same time. So this is a fixture. Considering authors, books, and orders, this is what a fixture looks like. In this case, I'm envisioning a situation where I want to have an orders display web page. And I'm going to do something fancy with the cells. So pending orders, shipped orders, and delivered orders, they're all going to they're going to be highlighted a little differently. So I want to put that data in the database, and then I want to run, I'm going to do the GET request against that page and make sure that the CSS styles are correct on those cells. Everybody with that for the most part? So this is what it looks like for me to have to do this. Now you can imagine that if I'm doing this over and over and over again for a real app, my fixtures are going to get very unwieldy very quickly. Instead, I could do this. That seems a lot better to me. Does anybody not think this looks better? You're very welcome to disagree with me. This seems very...
I would say that I don't want my model objects to know whether or not they're under test or have separate methods on those objects specifically for testing. I think that should be isolated.
Okay, and why? So let me make a quick statement.
You would have to test this as well, wouldn't you?
The model objects themselves do not have any understanding of being under test. The only thing that we have is this test create method, which is, well, I'll show you what it's going to be. So the data itself is not, there's no like under test. It's just, this is a fancy method for getting me something really easy, for getting my data really easy when I don't care really about what the data is.
Yeah, that's probably fine.
Okay. So in the beginning, when we did test and create methods, they looked something like this. We would allow you to pass in keyword args, And if it wasn't there, you would basically fill it with random data or some other data type particular to whatever that thing is. Because the reality is when I'm doing orders, the only thing that I care about in this is the status. I don't care about anything else. I'm not testing anything else. So I don't want to concern myself as a developer setting up that test about all the other data that that table needs in order for it to be successful. In reality, in an order table, it's probably going to be pretty wide, right? There's going to be a lot of things to track. But in this particular test, I don't care about any of those. All I care about is the status. So this is what a testing create method looked like early on. This wasn't hard, but we did have to do it in particular every time that we built an entity. One of my developers came up with the realization that we could actually create magic testing create methods which understood the types and correctly chose random values for any of the columns that we didn't specifically pass in data for. So now our testing create method on something that in reality this entity had 10 columns on it. If you look down at the testing create method, the only thing I have to worry about is creating a hierarchy, which is a relationship. And that's it. Everything else is getting taken care of by the parent testing create on our methods mixin. So I'm actually going to skip this. If you go out, if you're interested in what that testing create method looks like, you can go out to the book orders. Under the model utils, there's a methods mix-in, and you can go look at that and just see what we're doing. All we're doing is using SQAlchemy introspection to loop over the class, find all the columns, and for each column introspect this type and set it to some random value. There is an issue in there where we're actually setting numeric values to 0. We've since had a discussion and realized that we really should be setting it to a random numeric value to avoid false positives when testing for 0. And so if you copy that code, just change that one piece.
Why not just why not just use something like Factory Boy instead?
Yeah, so for me, it was because I was doing test and create long before Factory Boy came along, and it was just easier to stick with what we knew. Okay. If you were comfortable with that or liked it, by all means, use it.
So when I worked at Onshift, we tried using Factory Boy for a lot of stuff, and the problem is that you end up, when you're trying to do all the dependencies in Factory Boy, you end up having to maintain a bunch of code, and then the Factory Boy stuff ends up breaking, and then you've got bugs in your tests that you have to go and figure out why your tests are broken. It makes it really, really hard to figure out, is this a bug in my test or actually a bug in my code?
And that's actually the reason why I've avoided using an extra library, is because this is so drop dead simple that if it breaks, it has to be us. Because, so if we go back one, if the defaults aren't working for you for some reason, if you have some weird special condition, then you just override the testing create and pass it in as a keyword argument, and your default values won't overwrite it. So whenever you get into anything that's kind of weird or non-standard, you just set it up in the testing create that belongs to that entity. All right, any other questions about testing create or creating your data?
Do you unit test your factories?
Okay,
to make sure that they create the
so
properly?
In reality, almost every test that's working on the database exercises these, right? Because the only time I'm updating my testing create method is when I've got a test that needs something different. And so testing create is very generic, it's very standard, it's getting executed all the time to create these objects. And so the nice thing about this is if it breaks, the only place it's going to break is in your test, which is actually why we call it testing create, to kind of just give the developer an extra oomph that, look, this is only a testing method. We have other methods called add and edit on the objects that you can use if you're actually trying to add something where you care about the values that go into it. Does that make sense? Anything else on creating? So let's say hierarchy needed some kind of dependency, and its dependency needed a dependency and all the way up like 5 or 6 levels. Every testing create is responsible for getting all of its dependencies set up. So when I write the test, I really only have to care about the object I absolutely need. If for some reason, let's say I had a test where I need an order, but whatever I'm testing has a let's say I need the same publisher, right? Because whatever I'm testing requires that 2 orders be for a book that has the same publisher. In that case, I do publisher.testingCreate, and then I just pass that down through into the objects. Instead of letting them create their own publisher, I send them the publisher they should use, and they won't create the extra, they won't create a publisher for themselves. So this really frees you up as a developer, I've found, to only focus on what I care about in the test, and not get way sidetracked by the 5 or 6 levels deep of stuff that I'm going into. I don't even have to care about it. All I care about is the fact that I've got books or orders or whatever.
Does this work with, this is using SQL Alchemy, right?
So this is using SQL Alchemy, that's correct.
So, like, there's actually my, so would it work with NoSQL databases as well? That's my ignorance.
I think the principle would, because at the end of the day, all you really need for this to work is you need some kind of entity object that represents the data in the database.
Okay.
And you need a method on it or a factory library of some kind to create the entity with random data.
Okay.
And as long as you have that, this should work. Okay, so the next thing we want to do is we want to let our tests enforce good patterns. So one of the things that I've realized is that SQL Alchemy in particular allows you to do some pretty cool stuff, but its defaults don't always match the defaults that we have as an organization. For instance, we always want our ID to be ID, and we always want created timestamps and updated timestamps. It doesn't make a lot of sense for me to repeat that code over and over and over again. And in particular, we realized recently that we were doing datetime.now and not using UTC time, which is recommended at the database layer. And so one of the things we have now is we have a default columns mix-in, which basically adds our ID and our created and updated timestamps. And we make sure that that's present on every, here. So we make sure that that's present on every entity. And so what you see here is this is a test, and you'll notice that it's inheriting from entity base. Entity base is a class that enforces good patterns and assumptions that we're making as an organization about how we want our entities to be set up, so that I get a lot of tests by default simply by inheriting from entity base. You'll see here that I've listed out all my columns. I have a foreign key definition there on hierarchy ID. For instance, if I forgot to add the FK equals on the bottom line there, my test would fail and say, hey, I've recognized that history ID is a foreign key, but you didn't tell me in your test where it was supposed to point. Something that's not, I guess I'll go into that next. Any questions about entity base or why you would have your tests for your entity classes be standardized like this? Or confusion about what this really is? I realize I'm booking along now a little bit. Okay, so what patterns are we in particular enforcing at level 12? The first thing we're doing is we're checking for nulls. So the SQL Alchemy default on a column is for it to be nullable. I've found in my experience that most of the time that our columns are not nulls, and it's easy when you're adding a column and you're kind of in the middle of a thought process to forget to set the nullable. So in our tests, if you go back to the column check, the tests that use the column check definition assume if you've not specified required equals false, that it's true. And so these tests are enforcing that all of these columns are not nullable by default, which matches our organizational preferences, but can easily be overridden in the column check if that assumption is no longer valid. We can also validate unique columns, so you can send column check unique equals true. It'll validate and make sure that there's a unique set on it. This is really interesting. Does anybody use SQL Alchemy and looked really closely into how foreign key cascades relate to relationship cascades? It's actually really interesting. If you're not paying attention, you can end up making your database do a lot of extra work. So if you have a collection, and let's say you have authors, and you have an author.book, right? And that'll give you a list of all of the book entities that are associated with it. Well, now let's say that you go and you want a book display page. And so you decide to just loop through all your authors and then loop through all your books. In reality, what SQLAlchemy is doing is it's doing a select statements for every single author to get all of its books, rather than doing a join so that you have all that data. Now, I'd question about why you're looping over the entities anyway, but if you did that and if you didn't realize it, you're listing 1,000 authors on that page, or 1,000 authors on that page, and you're listing all their books with it, you're going to make 1,000 extra calls to your database to get each author's book. So there are some default cascades. There are some defaults for the relationship objects. There's some defaults for the foreign key. Like in almost all cases, whenever we have a relationship, we have a database foreign key. And in that case, I don't want SQLAlchemy to issue deletes for every item that's in that collection. So if I have an author and I have 100 books for that author and I delete the author, SQLAlchemy by default is going to load all 100 books, run through each one and issue either a delete or an update statement, and then delete the author. That's not what I want at all. I just want SQLAlchemy to delete the author because I've configured the foreign key on the database to do a cascade and delete all the author's books. But that stuff is really easy to miss when you're in the throes of things, trying to get your tests going. And so by default, we can test some of these things on our entities and making sure that we're following best practices as developers. Some other things we test is make sure we have timestamp columns, making sure that if we have timestamp columns, they're UTC. So we go through to whatever you're using for default or on update and make sure that that's not the .now method, that it's a .utc now or something like it. Our entity base also automatically adds and counts the record just to make sure that it's valid, that you can actually do the insert and select from the database. And this isn't actually implemented yet, but I have plans to make sure that for every column in the entity, you have a column check object, and you haven't forgot to add one, because I've been forgetting to add them lately. So I want to go back and get an error when I forget to add a column check to it. Next thing is we want our test to be as fast as possible. The first thing I want to say about this is don't do premature optimizations. Everybody should know that premature optimizations are the devil. You can make a lot of assumptions at the beginning of a project about what you think is going to be the problem and waste a bunch of time and have them actually not be the problem. A very good example of this is our entity base object that I've talked about previously. To test a null, it would try to insert a null value in the column. To test a foreign key, it would try to enter something that was not valid. And so that was requiring a database test, a database round trip for every one of those tests. We got to the point where we realized it was taking like 45 minutes to run all of our tests, and a lot of that time was being consumed by our automatic constraint tests. And so what we did is we realized, we're really not trying to make sure that SQLAlchemy or the database is functioning correctly. All we want to make sure is, as developers, we've set the right value. So we switched to doing SQLAlchemy introspection on the columns or the relationships, and that has sped up our test considerably. But I never in a million years would have guessed that at the very beginning when I was trying to figure out how can I make my entity base helpful. I wouldn't have thought that that would be a problem. Now, maybe you're already running at scale. Maybe you've got 10,000 tests, and in which case I'm going to have to put some thought into performance. But if you're starting with a small project, I'd say don't worry about performance till other stuff comes up. I'm going to just get all these out here. So avoid database round trips when possible. So for instance, if you had users and users could have multiple emails and all you want to do is test a user.emails to CSV, you don't actually need to commit all those records to the database because your entity object is doing all that work. They don't need to come from the database. So being smart about when you're actually committing things to the database or flushing to the database can be helpful. But once again, a lot of times I think the overhead of thinking about that every time may or may not pay off. It's just going to depend on how many tests you have and where your performance issues are. I talked about this already, testing the configuration in the case of our entity base class rather than testing the execution against the database. Knowing when to commit. So one of the things that we do when we, so if I have a order and it needs to create a book, I can send _commit equals false to book. And book will not commit. It will only add the object to the session, and it will also send underscore commit equals false to anything upstream, so that the only commit that I'm doing is the one on testing on order.testing create. So basically, testing create is by default going to do a commit, but when you're passing objects, when you're kind of walking back up the hierarchy, if you are smart about saying, hey, don't commit here, all those other objects won't issue commits, and you'll just get one big commit, one big insert, multiple inserts and one commit at the very end instead of multiple commits for that series. Be careful of network or VM issues. We had a situation where we were using a Microsoft SQL server on a VM, and we were using NAT networking by default from the host to the VM, and it was like hours slow. And it just, you ended up having to create a different type of network connection, and all of a sudden everything came back. But if you didn't ask other developers, why are these tests running, taking hours to run, or you're just like, wow, this just sucks, the tests are slow. It would have taken a lot longer to test. You could try tests with in-memory SQLite. We've done this before. The problem is you frequently run into incompatibilities between SQLite and your actual database, production database, if it's not SQLite. And so we've gone away from this. I know that, for instance, it can be really helpful if you have like a library that works with multiple database types, and you do most of your testing against SQLite, and then go back and only test the database particular code against its flavor. That'll make your tests run a lot quicker. Only run the tests you need. Learn how to use your tools. Nose and PyTest both allow you to run particular methods and then back your way out. So what I normally do is I'll run a test method, I'll run the test class, I'll run the test module, and then before I commit, I run all the tests across the entire app, and then also we'll have this continuous integration environment run all the tests across the entire app. So by starting small, my test iterations are really quick, and I only back out in succession as I'm basically finishing things up to make sure I didn't inadvertently break something else in a different location. You can also parallelize your tests, which is usually going to require you to have multiple databases to test against. Sorry, I did it to you guys again. Gals. All right, so flexible. So talking about migrations, I'm not really going to have time to go into this. But the key is you have to realize that there's 3 different parts of migrations. The first phase of a migration is anytime you create the new schema. The second phase of the migration is when you're going to clean up and remove the old schema. And the third part of the migration is when you have things that don't depend on the current schema. And you have to have your migration set up this way. If your migration does all 3 steps at once, for instance, if you were trying to take user emails, if you're trying to take, you have users.email, you want a user emails table because you realize you have more than one for each user. To test that migration correctly, you're going to need to create the user emails table, test it, test the migration from user.email to user emails before the migration deletes the user.emails attribute. And so you have to make sure that you build your migration in a way that's in chunks that match the way that you're going to need to test it. And you can get more details on this if you want by going to the slides and just seeing how I kind of worked it out there. I think I may have a couple minutes for tests or questions. Okay, thanks. If you want to ask questions, I'll be outside later if you have anything in particular you want to talk about.